I'm here with James Gortzman of Code.org. Thanks for having me into the office. This
Pleasure.
is great. So tell me, what is Code.org?
Right, so Code.org is a nonprofit. Our mission is to ensure that every student in America has the opportunity to learn computer science. So we are working with every school to get in there and teach computer science. We believe that computer science is one of these basic foundational skills that every student in America should have, right up there with reading, writing, and arithmetic. And we see our mission over the next 10, 15, 20 years to get to the point where eventually every student in this country is learning computer science alongside their other basic classes.
So that's a big ambitious
goal.
Right? And I know you just kicked off the Hour of Code. And that seemed like big success. I saw a lot of celebrities all the way down to a lot of founders all over the country, all over the world, tweeting and sharing what you guys are doing. What is your biggest challenge right now?
Sure. Yeah. Our single biggest challenge is by far working with schools and school districts. So if you think about how we are achieving our mission, there are three pieces to what we do. First piece is advocacy work, working with at the state and federal level on policy changes necessary to make our goal possible. So a great example is that in 35 of the 50 states right now, computer science doesn't count as a graduation requirement toward math and science. So every school in the country has some sort of math and science requirements. You have to take a certain number of credits in chemistry or algebra or whatever. CS typically doesn't count toward those, which is obviously a big reason not to take computer science. So, so we're trying to get those changed. That's relatively straightforward. We've actually just this week, Wisconsin just announced they're making that change. We've got Washington State to make their change back in April. That's a relatively straightforward thing. That'll take time, but eventually we think every state will recognize computer science as a science. The next step beyond that, by the way, is then to get every college to then recognize computer science as counting toward their entrance requirements in math and science. And that's actually a harder change to make happen. But we'll get there eventually. That's advocacy work. Second thing we're doing is on the education side, working directly with schools to put computer science into classrooms. Right now, only 10% of schools in this country, K through 12, teach computer science.
Wow.
That's crazy. That's actually down from 10 years ago.
Really?
So it's actually gone down. Yeah.
Interesting.
I know, it's crazy. So our step there is to work with every school to eventually offer computer science. We're doing that in a couple different ways. We're running a pilot program next fall, where we've identified a handful of school districts. We're working directly with that school district to put computer science into 8 to 15 different schools in that district. And put in means we're providing classes, complete, ready-to-go curriculum, and we're also doing professional development for their teachers. You're not going to hire a CS graduate right out of college to go work in K through 12 education. They're going to go work at a big startup or something. So for that to happen, we have to take existing math and science teachers and teach them how to teach our classes. And just as a side note, one really cool thing about the curriculums that we're offering, they're all flipped classroom curriculums, which mean instead of the typical model, which is all day long you hear a talking face do the lesson and then you do homework at night at home alone, we flip it around. At home alone, you're watching videos to learn the material, and then during the day in the class, you're actually doing the problem sets in pairs with other kids, and you're actually learning in a more collaborative environment. That's great because the teacher can actually watch you doing the work, give you feedback. It also means that we can recruit the best teachers in the world to teach the lesson. So we can do videos and tutorials with Bill Gates and Mark Zuckerberg and other kind of world-class educators or world-class tech luminaries. And then the actual classes can be more focused on the work. And that also makes it easier for the teacher, because now the teacher is more of a facilitator than having to be a PhD computer science expert. So that's a nice thing we're doing. That's off to a good start. That's really the long-term bulk of our focus. But if you think of that is solving the supply side, making sure that every school in America teaches computer science. We still have to address the demand side, which is making sure every student actually wants to learn computer science. And that's where things like Hour of Code come in. So Hour of Code is, you can think of it as a marketing campaign. It's basically an initiative to ensure that to get as many students as possible, as originally conceived of as an opportunity, to get as many students as possible to try programming for an hour. And hopefully realize and demystify this subject, because there's so many stereotypes and just myths around computer science. You have to be a math genius to program a computer. You have to be Bill Gates. You have to be a white male nerd. That if you're black, or if you're a girl, or if you're not a nerd, or if you're cool, you shouldn't be learning computer science. Nothing can be farther from the truth. We believe very firmly anyone can learn the program. Everyone should learn the program. That there are basic benefits to learning the code, even if you have no plan on working professionally in the IT industry. If you don't, even if your ambition is not to go work at Google one day, you're still going to benefit from learning computer science, because at its root, computer science is not programming. And computer science at root is computational thinking. It's learning how to take a big hard problem, break it down into pieces, and use computers to solve those pieces.
in a similar way, I mean, we learn algebra and we learn calculus in
Right.
high school and into college, but you don't necessarily, not everybody uses those on a day-to-day
Yeah, I mean,
basis, but it's more about...
Absolutely. People always say to us, isn't computer science a vocational field, not foundational?
Sure.
And we're like, yeah, in the same way that math is vocational if you're going to become a mathematician.
Right.
But if you don't become a mathematician, math is not vocational, it's foundational. In the
Right.
same way, yeah, but computer science might be vocational if you're going to go be a professional programmer. But even then, there's huge differences between learning to program a computer and learning how to, say, fix a car.
Right.
Fixing a car is about solving a transportation problem. You can always take the bus.
Right.
Fixing a computer, learning to program a computer is fundamentally a creative endeavor. A computer is a really unique tool in that it's primarily a tool of creative expression. You learn how to program a computer, you can create almost anything.
Right.
And what you're not just limited to building apps for sale. I mean, you can literally solve problems. You can create art, expressions of art. You can create productivity applications. You can make the world a better place. There's so many things you can do with computer science. And the other thing we often talk to people about is in terms of career. One of the reasons we started this in the first place was simply that the number of jobs in computer science is growing 3 times faster than the number of students studying computer science.
Right.
And in another, the projected by 2020, there'll be like 1 million jobs being unfilled.
Right.
That, because we're not filling them, we're rather going to be filling them by, finding folks overseas and saying, please come live in America to solve these jobs for us, or simply losing our competitive edge to other countries. And there are already countries like UK and China and others where every student's required to take a year or two of computer science.
Interesting.
And we want to get there eventually in America. For now, we're content to simply work to getting it into schools, and then later we'll figure out how do we get it so that every student literally has to take computer science.
Are you guys looking at those programs overseas and seeing, kind of taking what's good out of them and trying to bring that to America, or is this just is that just a different culture?
No,
how does that work into what you're doing?
So, no, we're not looking too closely at the specifics. I mean,
Sure.
Take UK, for example. The program in UK right now is literally basically a decree from on top. We will teach computer science in every classroom.
Right.
They've not yet figured out the details how exactly they're going to execute that.
Okay.
And in China, it's pretty basic. It just means that every high school student, by the time they graduate high school, has taken a year of computer science.
Right.
You're
going kind of bottom up.
But yeah,
right?
bottom a little bit. We look at the entire problem K through 12, and frankly, we believe that computer science is not one of the things you have to put off until like your high school age. We believe that even young kids can be learning to program at some level, and so we have 2 very different programs. One's K through 8, one is 9 through 12. And K through 8, in 9 through 12, we have 2 classes we're kind of pushing. One is called Exploring Computer Science.
Mm-hmm.
It was pioneered by UCLA and is used right now in the LAUSD school system. And it's a great, broad-based interdisciplinary computer science that is not just programming. It's programming, it's web design, it's big data management. It's a really neat class. And it was designed to be culturally relevant. It's designed to appeal to a very wide range of kids.
Okay.
And be equally attractive to women and men
Sure.
and have broad bases.
Trying to make coding cool, right?
It's trying to make and applicable and relevant
Right.
and interesting. It's a great class. We're a big fan of ECS. That's one of the classes we're kind of pushing.
Sure.
Second class we're pushing is a brand new class that we're actually co-developing with the NSF, and the College Board, called AP Computer Science Principles, or APCSP.
Okay.
It's a new AP Science class, doesn't exist yet. AP Computer Science A is the same AP Science, Computer Science class that was around when I was a student.
Okay.
It is a very straightforward Java programming class. Nothing wrong with it.
Sure.
It is a very dry class, and it has typically 82% male, 18% female ratio, which
Okay.
is not uncommon in the CS industry. Very few students take it. In fact, the AP Computer Science exam participation rates are down there with like music theory and Latin.
Okay.
It's 6 times more students take AP Calculus than AP Computer Science.
Okay.
Despite frankly, I think AP Science being nothing as calculus, AP Computer Science I think is far more relevant to a lot of careers than AP Calculus is going to be. So. Just given where the jobs are. So
Sure.
AP Computer Science Principles is meant to be similar to ECS, a very rigorous but still broad-based computer science class, which is going to be more than just programming. It's going to be a much wider range of CS topics, which is great. So that's 9 through 12.
Right.
K through 8, we have put together a series of online tutorials
Okay.
that can be applied in any K through 8 classroom. And the idea is that a teacher can apply this module in a math class or a science class and say, okay, the next 6 weeks we're doing a module in computer programming, and it's we're going to be doing a series of exercises on tablets or PCs or Macs or even offline,
Right.
and learn the basics of computer science that way.
What are they doing in those classes, right?
Yeah.
I'm assuming they're not, and then maybe
No,
I'm
they're-
wrong,
they're
they're not
not
pulling out the
typing.
computer
Yeah.
and for else statements and everything.
You're exactly right. So, so you mentioned the Hour of Code just now. The Hour of Code is an amazing initiative which we launched. Well, actually, we're in the middle of it this week. So Monday started CS Education Week.
Right.
During CS Education Week, our goal is to get as many people as possible to do this Hour of Code.
Sure.
Our original goal was 10 million students. As of today, 3.5 days in, we just passed 12 million students.
That's awesome.
Which is
congratulations.
Unbelievable.
Yeah.
And that's 12 million students doing a first hour-long programming. And what's
Right.
especially cool with that is it's 52% female so far.
Wow.
And what's neat about that statistic is that means that more girls have done an hour-long programming introduction this week than in the entire history of computer science to date.
Really?
Which is crazy, but true. Another crazy statistic is that we've had more African Americans and more Hispanic students do this first hour-long introduction to programming than also in the entire history of computers, by like a factor of multiple, like 3 or 4x.
Okay.
Which is awesome and also terrible because it just talks about how poorly we've done a job of getting computer science out into broader areas of just these white male.
Right. Up to this
narrative.
point.
Up to this
So
point.
that's the good part.
Going forward, we're changing it.
Yeah.
We're really trying to make the point anyone can and should learn computer science, and I think we're being effective at that. But the Hour of Code is really just the first hour. And obviously, if we just stopped at that point,
Right.
it would have been splashy, but not that effective.
Sure.
The goal of the Hour of Code, like I said, is demystify it, make the point that you want to do, and encourage kids who want to go on further. Either by taking a CS class, if one is available at their school, so
Sure.
a recruiting tool, or going online and continuing their education themselves. And so we've got it turns out that the Hour of Code, the first hour, there's a series of different tutorials. One of the tutorials we built ourselves, and that hour is actually just the first hour of a 20-hour-long curriculum we built, and that's the curriculum that we're encouraging teachers to use in K through 8. And that curriculum is based on a visual language called Blockly, which looks like Scratch if you've ever seen it. It's dragging and dropping programming blocks together.
Okay.
So you're building a programming by dragging and dropping these blocks of code together.
Okay.
And it's a series of puzzles and levels you're trying to solve, like a video game. So
Okay.
here's a challenge, solve the challenge by writing code.
Right.
The first lesson teaches you the very basics of commands, the idea, even just the idea that you tell a computer what to do by writing commands.
Right.
For loops are in there, while loops are in there, if then, else
Yeah.
statements are in there, but again, they're all visual.
Right.
And then future lessons kind of go on from there and introduce an additional functions and variables, and by the time you've done this 20 hours, you're not necessarily writing Java, but you now know the basics of these of logical thinking. You've learned
Sure.
the basics of these commands, and in fact, one of the cool things is that all these blocks are actually correspond to JavaScript. So you can push a button and see the JavaScript you've just written by dragging and dropping these blocks together.
Right.
And then from there, you're ready to go on to a Code Academy or a Khan Academy or one of the many other kind of MOOCs that are out there now
Right.
to learn how to code.
That's excellent. Well, not a lot of people, I think, who are watching the videos on our website are going to be K through 12,
Mhm.
right?
Mhm.
But how can they reach out? How can
Sure.
they help, and what can they do to further the mission of
Sure,
Code
sure.
Over?
So if you're watching this and you're interested, there's a lot of things you can do. If you are, say, above K through 12, here's what you can do. If you have kids, you can bring coding to your kids. You can do it by going to your teacher, your kid's teacher, your school system, and say, hey, if your kid's school has computer science classes, great, tell your kids to take computer science classes. If your kid's school does not have computer science classes, go to the principal, go to the superintendent, and say, we need computer science classes in our schools. Our kids need to learn these things. Let's make that happen. And there's a lot of resources out there. We have resources for that. A lot of times, just having the principal get enough pressure from the parents saying, we really want this, and the principals will respond and figure out a way to get those classes into their school if they feel that the parents are really asking for it.
Sure.
If you don't have kids and you're an adult and you simply want to learn for yourself, there's a ton of online resources out there. You can go to code.org. We have a tab called Beyond the Hour of Code. It's not just for kids. I mean,
Sure.
the stuff we have is available for all ages. You can go there. There's a ton of resources. We have links to all the best online resources out there for learning how to code, and you can do one of those classes yourself. It's an amazing time for learning how to code. I mean, if you're interested in computer science, the days of having to learn from a book or take a class at community college are long past. You can now take, Harvard CS50 is one of the best computer science classes out there and that's now available online. I think it's for free. There's a ton of classes out there, either for free or for a modest amount of money, which are great. So that's a great way to learn. Of course, you can also get a book, but there's a lot of resources out there that we link to.
Sure.
And then if you are a professional and you already know how to code, but you think what we're doing is a great mission and you want to help, go to our website and sign up as a volunteer. We have a place where CS professionals can say that I want to help. I want to help make computer science happen for students. And it can be simply sign a petition to encourage CS into your local schools. It can be signed up as a natural volunteer where we're not currently doing much with that list, but our plan in the near future is to start helping match these volunteers with schools or other organizations that want to, help have professionals help teach programming.
Sure, that's excellent. Well, I guess further the progress of computer science education in America and keep us competitive, right?
That's our thinking. I mean, computer science was born in America. Arguably, Ava Lovelace from England was maybe one of the first programmers, but I would say computer science, as we think of it, really was pioneered here in America. And computer industry, the personal computer, tablets, these are all American innovations. The internet, these all really were founded here. And we're in danger of losing that initiative, especially going forward, if we're not able to continue generating the best and brightest computer scientists in the world. And so we need to keep that up.
Maybe Code.org can help, and you can too.
That's right, you can too. Make a difference.
So thanks for having me into the office.
Thank you very much for coming.
Check out Code.org.